DES stands for Data Encryption Standard. So it is a symmetric key block cipher. It is the implementation of Feistel cipher. So how does the DES work? So a 64-bit plain text is first taken. So the principle of DES is very simple. So it starts with dividing the plain text message into block of size 64-bit each with its initial permutation. So after the initial permutation on 64-bit block, the block is then divided into two halves of 32-bit called the left plain text and the right plain text, each of 32-bit. The left plain text and the right plain text undergoes through 16 rounds of encryption process along with 16 different keys for each round. After 16 rounds of encryption process, the left plain text and the right plain text gets combined and the final permutation is performed on these combined blocks. The final permutation produces a 64-bit of ciphertext. So now, what is initial permutation? So, initial permutation is the process of rearranging or shuffling each bit of original plain text block with any other random bit of same plain text message of the block. Now, initial permutation, rearranging the bits of plain text produces two halves of permuted blocks, that is, the left plain text and the right plain text. Then comes the key discarding process. So, a 56-bit key is used during encryption process. 56-bit key is transformed into 48-bit key by discarding every 8 bit of the initial key. So we know that the 56-bit key is used during encryption process. Here the 56-bit key is transformed into 48-bit key by discarding every 8 bit of the initial key. Then we come to expansion permutation. The right half is expanded from 32 bits to 48 bits. And during this process, the bits are permuted, hence called as expansion permutation. The resulting output of XOR operation in this process is given to next step, which is the S-box substitution. So the output of the expansion permutation is the input for the S-box substitution. So S-box substitution. Substitution is the process which accepts 48-bit key and expanded right plain text of 48-bit which gets XORed and produces 32-bit output. So a 32-bit output is produced in the S-box substitution. Now the output of the S-box input to the P-box. So the output of the S-box is the input to the P-box. In the S-box substitution, the substitution is performed using 8 substitution boxes. This is the reason it is called as S-box substitution. The input for each S-box is 6-bit, which produces output of 4-bit. The output of S-box is then combined to form the 32-bit block. Now the output of S-box is the input for the P-box permutation. Now this is similar to the initial permutation. 32-bit output from 8 boxes is permuted. So as we know, the output of S-box is the input to the P-box permutation. So in P-box, in which the 32 bits are permuted using straightforward permutation mechanism, that is the replacement of each bit with another bit in the specified table, as called as P-box permutation. It is called as a P-box permutation. Then XOR and swap. The output of the XOR operation becomes new right plain text and the old right plain text becomes the new left plain text. So still this step we have performed all operations on 32-bit right plain text only. The left plain text was not touched. But then after the XOR operation, the output of XOR operation becomes new right plain text, and the previous right plain text becomes the new left plain text. The old right plain text will become the left new plain text. Then comes the final permutation. After completing successful 16 rounds, after the completion of successful 16 rounds, it produces 64-bit encrypted block. So when the final permutation is performed after the completion of 16 rounds.